Hello, welcome to ANS Solver. This is the fourth question of the paper. So as you can see, there's a diagram that shows the graph with the probability density function f. Okay, where a is more than 0.5. So the graph is between x equals to 0 and x equals to a, and is a straight line parallel to x-axis. So we need to find the probability that x is less than 0.5. Now I know, because this is a parallel line, this will have a function like y equals to k, correct? Y equals to a constant, whatever this y axis is or y coordinate is. So now what we basically need to do is, we know how do we find this y coordinate here in terms of a. As you can see, this is a rectangle. The area of a rectangle is given by L into B. Agreed? We know the total probability, because it's a probability density function. The total area is 1 equals to the length into, I can say the breadth is a, correct? Because this is the breadth, so this is a here. So I can say the length is equal to 1 over a, which basically means this is 1 over a. That means a function is y equals to 1 over a. Got it? Now, because I know a is more than 0.5, I know 0.5 lies somewhere here. So I need to calculate the area here. So what I can simply do is, I know the function is 1 over a. So I can integrate 1 over a dx with the limits from 0 to half, because it's 0.5, correct? So now what I can simply do is, first, while the integration of 1 over a is simply 1 over ax with the limits 0 and half. So first I'll put half in the place of x. So I get 1 over 2a there. Minus, when I put 0, I know I'll get 0. So the final answer is simply 1 over 2a. Got it? Now, find e of x in terms of a. So the formula of e of x is the limits, the highest limit to the lowest limit to the highest limit with x into the f of x dx. So what we basically need to do is, we know our limits is basically from 0 to a, correct? I know x into f of x. I know my f of x is 1 over a, which we got in part 1, correct? This is what we got. Now what I can simply do is, I can integrate this from 0 to a as 1 over ax dx. So this integration will basically be 1 over a into x square by 2 with the limits 0 and a, correct? So now I can write this as a square by 2a, sorry, minus 0, correct? Because when I put 0 in the place of x, this full thing will become 0. So now a square over 2a is simply a over 2, which is basically my e of x in terms of a. Now I need the variance of x. So the variance, okay, there's a master formula for this. The variance of x is basically e of x square minus the mean square. Okay, so the e of x square is given by the formula, the integration of x square into the f of x. So this is basically the integration of, I know this is simply from 0 to a with 1 over a x square dx. So when I integrate this, I get 1 over a x cube over 3 with 0 and a. So now when I put a in the place of x, I get a cube by 3a minus 0, which basically gives me a square by 3. Got it? Now what I know is, I know my variance formula is simple. So it's variance of x, which is equal to e of x square we know is a square by 3 minus the mean which I calculated was a upon 2, the whole square. So this is basically a square by 3 minus a square by 4. Correct? Now I can simply do cross multiplication for my LCM. So I can write this as 4a square minus 3a square over 3 into 4, which basically can be written as a square by 12, which is what I needed to prove. So this is basically the answer of the third part. Now the B part. A random variable t, okay, has a probability density function given by the function. Find the value of b such that p of t, which is less than equal to b, is equal to 3 over 4. Okay, so now what I basically need to do is, I know this probability is 0.75. That means whatever b is, it's my upper quartile. So what I can basically do is, I can integrate this from the lowest limit, which is 2, to let's say b, okay, and I know the function is basically 3 over 2 multiplied by t minus 1 raised to minus 2, correct? I can write it like this when I take it to the numerator, and I know this integration, okay, is equal to 3 over 4. So now I can write this as 3 over 2 with the integration from 2 to b with t minus 1 whole raised to minus 2 dx is equal to 3 over 4. So this can be written as 3 over 2. So the integration for this is simply t minus 1 raised to minus 2 plus 1 over minus 2 plus 1, over minus 2 plus 1 into the differentiation of t minus 1, which I know is simply 1, with the integration of 2 with the limits of 2 and b. Okay, now what I can do is, I can write this as 3 over 2 with t minus 1 minus 2 plus 1 is basically minus 1 over minus 2 plus 1 is basically minus 1 with 2 and b. So this can finally be written as 3 over 2 with the integration minus 1 over t minus 1 with the limits 2 and b. So now I can write this as 3 over 2 with minus 1 over t is basically b. So I can say b minus 1, okay, minus of 1 over t I know is 2 now, so 2 minus 1 is 1. And I know this is equal to 3 over 4. So I can basically write this as 3 over 2 with minus 1 over b minus 1. Sorry, same mistake twice. Yeah, plus 1 is equal to 3 over 4. Now what I can do is, I can cut 3 on both sides, and I can simply write this as minus 1 over b minus 1 plus 1 is equal to 1 over 2. So now this can be written as 1 minus half equals to 1 over b minus 1. So 1 minus half is simply half, which is equal to 1 over b minus 1, which can be written as b minus 1 equals to 2, which gives me my b basically as 2 plus 1, which gives me my b as 3, which is the value of b which we needed to find. Okay, simple question.